everyone. This is John Demick. I'm the CTO of a company called HyperCurrent, and I'm excited to present today around automating contract-centric API experiences to accelerate front-end development. Specifically, I'm going to talk about our experience at HyperCurrent, building out a product and then using APIs and API contracts to accelerate the delivery of that product across a globally distributed team. Who is HyperCurrent? Just to give you some context on our company. So we're a technology startup delivering software to help enterprises turn their APIs and microservices investments into profit centers. We currently have customers in the financial services, insurance, healthcare, and federal government verticals. Then in terms of the team that built the product, which I'll talk about in a second, we essentially have a core backend team, and myself included, we're all full stack JVM-centric developers, 15 plus years of experience. The front-end team is JavaScript, Salesforce-centric developers, and then in terms of both teams, we're split across 3 geographies and time zones. Now, in terms of the product we built, so we built something called ProfitStream. So ProfitStream is a distributed ledger-based enterprise API chargeback and monetization platform. And essentially what it enables organizations to do is to monetize their API and microservice investments by metering API transactions across lines of business, between central IT and lines of business, and even across distributed organizations. And then it has the ability then to take that metering data and then do things like send invoices, manage SLA rebates, and essentially do everything around chargeback and monetization for APIs for a large enterprise. Now, in terms of this product, we started the initial analysis and architecture almost a year ago, so in the September-October-ish timeframe in 2019. What we quickly realized is that this thing, based on the input we have from the various clients of ours that were interested in it, it was going to be totally non-trivial. So the first major hurdle we had to deal with is that from a persona standpoint, we knew we needed at least 3 user interfaces. So we needed essentially a single page web app, JavaScript, React web application that caters towards a business user who would consume the data from the API monetization and chargeback services. In addition to that, we also had to cater to business personas who were in the Salesforce ecosystem. So we also realized that we needed a Salesforce Lightning interface. So there was a single pane of glass for our users who were in the Salesforce ecosystem. And then finally, we knew from an operational standpoint that we needed some sort of command line that let administrators configure and then operate the software at scale. Then also do things like scripting and integrate it with various DevOps moving parts. So that this piece of the use cases will be the focus of this talk. But in addition to this use case around the user interfaces, we also had a bunch of other non-trivial stuff we had to contend with. So because this product ProfitStream is dealing with financial data, we had to integrate to multiple financial systems of record. So again, things like Salesforce, Oracle Financials, Microsoft Dynamics. The data model and business logic for this, both from an internal data modeling standpoint, as well as just the data models we presented to the user interfaces, this was also non-trivial, right? So we had a relational backend database, we had the distributed ledger piece of it, and all this needed to be kind of condensed in a way that was consumable by our front-end developers who didn't necessarily know a lot about things like chargeback use cases or distributed ledgers or things to that effect. We also had to support multiple deployment models. So, knowing that our customers would be in the financial services and government kind of vectors, they had on-premise deployment requirements, many had private cloud initiatives, and we also obviously had to support hosted models as well as public cloud models. And then finally, for anyone who's done any kind of enterprise application development, just all the usual suspects that you tend to rinse and repeat when you build these things. So we had to deal with integrating with arbitrary SSO providers and the OAuth protocol in particular, and then with vendors around that like Ping Federate, Okta and Active Directory. We also had to have SLAs for our own software, right? So that meant having cross-cutting concerns addressed like rate limiting and things like circuit breakers. So to summarize, just a lot of various difficult moving parts that we had to contend with from an analysis and architecture standpoint before we wrote any code at all. So when the core team got together, we landed on a handful of patterns and techniques that we were going to apply to address all the complexity of the previous slide. And essentially what I'm going to spend the rest of this talk addressing is the techniques and patterns that we chose to use. So to summarize, we landed on a combination of domain-driven design, strategic and tactical patterns. Obviously, using RESTful APIs. And then in terms of the implementation of the RESTful APIs, leveraging Spring Boot and then the Kotlin language. And then finally, leveraging Kong both as a metering solution as well as eating our own dog food in terms of using it to address the enterprise cross-cutting concerns I just talked about. So things like rate limiting, throttling, circuit breaking, et cetera. And essentially these techniques let us go from product inception to MVP, using essentially APIs as the foundation. Now, given all those various techniques, we needed a way to pull those together. So specifically, our front-end developers weren't totally terrified by what could have been a ton of complexity in terms of the APIs themselves. So we also decided early on to heavily leverage API contracts to make the front-end development experience as seamless and mitigated from a risk standpoint as we could. Now, for those of you who aren't familiar, API contracts provide a documented interface to interact with an API. So essentially, it provides guardrails for developers to understand how the API's endpoints and then its data types can be accessed and then used within their applications. And this essentially lays the foundation for a streamlined developer experience. So the idea here is that initially for our own front-end development team, then ultimately for any other maybe third-party or customer teams that wanted to extend our product, we wanted to make sure that their experience interacting with our product was as straightforward as possible. So this is where a lot of the benefits for having API contracts comes into play. So you get things like auto-generated platform SDKs. So for instance, we were able to quickly produce both JavaScript and Java SDKs for a profit stream. So this meant that developers could just bring these libraries into their projects and start immediately accessing the APIs and data types we were exposing. You also get things like auto-generated documentation. So we were able to generate something like 60 pages of very nicely formatted HTML and PDFs that documented all the different endpoints and data types that we were exposing in our application. And then finally, you get things like developer portals, right? So the ability, using the contracts, to push a button and then expose out both the SDKs, the documentation, and the API itself in a way that lets developers quickly sign up and access it. So again, a bunch of stuff you get that's super useful from using an API contract approach. Now, in terms of the API contracts themselves, there's essentially two major API contract definition languages that are in play today. So the first one, and this is probably more popular of the two, is something called Swagger, and it was renamed relatively recently to the Open API specification. And then the second standard is something called RAML. And what I'm going to do now is talk about how these standards play into the two sorts of schools of thought in terms of how one actually produces these API contracts. So essentially, in terms of building or defining API contracts, there's two schools of thought. So the first school of thought involves a top-down approach. So in top-down API contract development, the contract is defined first and the code is implemented second. And then with the bottom-up approach, you write the code first. So you basically build your API, and then once you get to a point where the API is usable, you generate a contract as an artifact from that build. There are significant pros and cons for each of these approaches. So I'm going to talk about now what those pros and cons are briefly, and then I'm going to talk about the approach that we landed at HyperCurrent, building out the profit stream API. So top-down contract development. So with top-down contract development, generally a developer will collaborate with with other people as part of the contract definition to write the API contract first. So this means that before anyone touches any code at all, there's a design first approach that involves iteration, where the API designer works with the API consumers, and they essentially collaborate on the API design to ensure that the API meets the consumer's requirements. And you know, as a side effect of this approach, since you have, you know, obviously a human being writing these things, these contracts are also generally readable by humans. So this means that someone looking at the API contract, you know, they should be able to understand pretty quickly what it does without having to go and like bring it into an IDE or jump through any kind of hoops in terms of understanding what it is because it's too complex or anything to that effect. Now, in terms of the cons with contract-based top-down development, the design tooling tends to be awkward for it. So generally, you need to do, you know, browser-based IDE sort of stuff to design the APIs. Some of them are form-based. It also requires learning a new language. So this means in addition to whatever backend stack you've landed on to build your API in, you now need to have your developers learn some new contract language to go define the front end of their API. And also, I think this is probably the biggest one for me. This approach almost always requires code generation. So for anyone who's dealt with code generation, there's a bunch of associated complexity that comes along with that. Namely, it means that every time you touch the contract, that usually has a bunch of cascading implications to the backend code once you do the contract generation. I think the final piece is that, again, in my personal experience, I find implementing cross-cutting functionality difficult with top-down contract development. So even though there tend to be mechanisms to express things like pagination and security, shared data types, et cetera, I usually find that doing this is awkward and, again, doesn't really lend itself well when the backend code is generated. Now, the other school of thought in terms of contract development is doing it from the bottom up. So in this approach, developers auto-generate a contract at build time, and then essentially it's always in sync with whatever the code is. So using this approach, a developer might write an API using Java or Node.js or something. And then as part of the build process, when this artifact is built, it will generate the API contract as a side effect. So this means that the API contract is always in sync with the code. This is in contrast with the top-down approach, where depending on whether or not the code has been auto-generated on the back end, the contract may or may not actually be in sync with what's actually implemented. Other major pro here is that developers don't need to worry too much about the contract definition language. They shouldn't be totally ignorant of it, but they don't need to be experts in it because essentially this happens as a side effect of the build process. Now, in terms of the cons here, and this is something I've personally been bit with, is that bottom-up contracts, if you're not careful about how you're generating the contracts, it becomes really easy to couple the generated contracts with your backend database schemas. So, you know, naively, this might seem like a good thing. Like basically, you know, you point something at your database schemas and you automatically get a RESTful API. The real danger here is that once you do that, you've automatically coupled your front-end user interfaces to your backend database schemas. And now that's makes it very difficult to go and do, to evolve your data models and schemas going forward. The other major risk, and anyone who has any experience with SOAP and these sorts of approaches, is that there's a very real risk of the generated contracts being super complicated and then consequently non-human readable. So yeah, so again, some pretty significant pros, but also significant cons for this approach and then the top-down approach. So what did we choose to do with Profit Stream? So essentially, we wanted the best of both worlds, right? So you know, from my standpoint, making much of the major architectural decisions, I wanted the ability for our front-end developers to be able to collaborate with the API design for us to quickly push out API design changes. But then I also didn't want my developers to have to worry about learning something like RAML or writing Swagger by hand to define the contracts themselves. And then again, just from my my background in doing DevOps and other sorts of things, I also very much like the idea of contracts being auto-generated, right? Because this means that I can be sure that when there are code changes, that these are reflected in the contracts that the downstream applications are consuming. So essentially what we've done is we've landed on a hybrid approach that we call middle out, that takes advantage of both styles, and it uses a combination of the following techniques, which I'll dive into. But essentially we used the domain-driven design strategic hexagonal architecture pattern, the tactical anti-corruption layer and DTO patterns. And then we also, from a cross-cutting concern standpoint, leveraged annotation-driven documentation to generate the contracts, as well as API policies to address, address the more operational cross-cutting concerns that I talked about previously. So the first pattern we used to accelerate the API contract development was leveraging domain-driven design and hexagonal architecture. So for those who aren't familiar, hexagonal architecture basically means that you have your core domain model and data types, and then essentially you have those at the center of your hexagon, and then surrounding that hexagon are ports and adapters, which for all intents and purposes protect the domain model from corrupting interfaces. So when I talked about before about coupling, coupling your data models and schemas to your API contracts, it's this approach that lets you avoid that. So this is the idea that you surround the data model with things like REST controllers and then serialization layers, and then you're able to essentially support things like concurrent front-end UIs and then integration with downstream and upstream systems of record, but having to worry about these things corrupting your core data model. So the example I like to use is that if you're integrating with something like NetSuite or Salesforce, or you're integrating with a front-end development team that's using a JavaScript framework like React, those concerns should not impact anything in your core data model. That needs to be really specific to the business and the business use cases that you're implementing. So hexagonal architecture is essentially the approach that gets you there. This also lays the foundation for the approaches I'm going to talk about next, which let us get to this middle-out approach in terms of getting the best world of API contract design. So the next accelerator that we leveraged to get to this API sort of contract nirvana, for lack of a better term, is leveraging Kotlin as an implementation language. So, and you'll see why this is relevant in a few minutes, but Kotlin, for those who aren't familiar, is an object-oriented functional JVM language. It was created by JetBrains. So if anyone's used the IntelliJ IDE, that's the company who's behind that. Kotlin was initially popularized in the Android world, but it's starting to get a lot of traction in the backend and server-side world. And then specifically, like just some of the features that our core team found really exciting about Kotlin are things like data classes, coroutines, its concise syntax, null safety, type inference, and some other things. This is essentially what makes Kotlin a really nice language for implementing APIs. Now, in terms of the anti-corruption layer, right? So just kind of looping back to the hexagonal architecture. For our particular application, we have our core domain model defined as Kotlin classes, and then we have this surrounded by Spring controllers, which define our RESTful endpoints. So Spring essentially serves as the adapter between external API access and then our core domain. We leverage the data transfer object pattern, so the DTO pattern, so that essentially leverages Kotlin data classes to serialize data types back and forth from the different REST controllers to the front-end interfaces. The DTOs are purely for serialization, deserialization. There's no business logic there. They're just basically just used to transport data back and forth from the different user interfaces over our REST API. And even the controllers themselves are they're essentially dumb. They basically don't implement business logic beyond doing things like handling headers and other sorts of stuff from an authentication and authorization standpoint. But essentially, whenever they do anything that involves the core domain, they interact with service and repository classes. Now, the next API accelerator we use, and this is sort of one of the core pillars of this talk, is the piece that bridges the top-down and then the bottom-up API development. So rather than have the developers handwrite in our case, the Swagger contracts, we instead let them document the anti-corruption layer and the DTO layers I just talked about with something called SpringFox annotations. So essentially what these do is they let you use Kotlin or Java annotations on your methods and your data classes. And then as part of the build time, these annotations will produce fully documented Swagger contract along with the data types. So this is the main piece that lets us get the benefits of both worlds, right? So this combination of using hexagonal architecture, anti-corruption layers, and DTOs in combination with annotation-driven API documentation lets us protect our core data model and schemas while also automatically exposing API contracts. And then in conjunction with Kotlin, this basically forms a mini domain-specific language, right? So with very little developer sort of cognitive overhead or even effort, it becomes really easy for us to define API contracts. It also makes it easy from us, again, from a DevOps standpoint, to put guardrails in place in terms of doing things like sonar cube checks to make sure that our controller classes and data DTOs are all annotated with the annotations as well, right? So let's just programmatically enforce that things will produce documentation. So you get a huge amount of power coming from these approaches. Now, the other piece, so this is now we're into the cross-cutting concerns part. So this is what I'm going to talk about, some of the help we get from Spring Boot, and then a lot of the help we get from Kong in terms of our cross-cutting concerns. So on the backend implementation, Spring Boot is a big help to us because it has various accelerators in the framework that let us do things like pagination, sorting, serialization, deserialization to multiple formats like JSON, CSV, and XML, as well as doing logging, auditing, and data repositories. So again, this saved us a ton of time on the back end from saving our developers from having to reinvent the wheel for a lot of these use cases. And then also from an enterprise API cross-cutting concern standpoint, Kong is a huge help for us here. So in terms of our core business use case, so just going back to profit stream and the fact it's doing API metering and chargeback, we were able to very easily build a Kong plugin that lets us to meter and roll up API charging transaction data, right? So essentially this means that we can deploy Kong to our customers who are using profit stream, and it gives us a way to asynchronously collect and meter API traffic going through the Kong proxies. The other major piece, and this is where we're using Kong in our own application, is we're able to put Kong in front of our API and then get a lot of the stuff that would otherwise take us a lot of development effort from an operational standpoint. It is implementing things like rate limiting, governance, security, and circuit breaking, right? So just security alone, this having the the ability to leverage OAuth and SSO features in Kong, as well as doing the the SLA enforcement, so rate limiting, governance. This is all things that would be non-trivial for my team to build, and we sort of just get out of the box from using Kong as an API gateway layer. And then finally, just a circuit breaking, right? So when we have to maintain our own SLAs, particularly for our own hosted models of this, the ability to proactively push any kind of latencies out to the client so they can handle on the client side. Leveraging that with circuit breaking is a huge boon to to our product and its stability. So now to summarize, I sort of quickly go through the lessons learned from moving just from the inception of this product to MVP. So essentially, after the inception and architecture stage, we got to MVP, kind of general availability of profit stream within 6 months. So this was, using the highly skilled core team that I mentioned at the beginning of the presentation, as well as the overseas UI UX teams. The initial estimates we had doing this with a traditional Java-based stack or a traditional either top-down or bottom-up contract-based approach, we're thinking it would have taken around twice the amount of developer resources. So it would have pushed us more into like, a year to MVP. And then, twice the amount of resources, then 2 to 3 times the amount of time, right? So a year to 18 months to get from inception to MVP. In terms of productivity gains, just back of the napkin calculations, I'm guessing we got 200 to 300% productivity gains using these techniques. Again, the Kong plugin architecture, not having to reinvent the wheel for security and governance, that saved us on the low end 2 months, if not more than that. So again, just a huge amount of velocity achieved by leveraging Kong for that piece. In terms of the API contract turnaround time, we're at the point now where our cadence with the front-end developers, we can usually turn their feedback in and get it deployed in a few minutes. So basically, we'll get a pull request from the front-end team, we'll integrate that in, check it in, and then our build process will push the new API out, the API portal, and the back end. And again, it can happen within a few minutes, assuming the API contract changes are trivial from a semantic standpoint. The client-side code generation techniques. So again, I talked about this, but the fact that we're able to just automatically produce Java and JavaScript SDKs, that's particularly simplified the CLI development. We basically got the CLI written, I want to say, in like 7 days or something. It was super quick to get that done using the auto-generated Java SDK. And then just from a strategic standpoint, having done this product, we've built a bunch of our own internal core libraries, and I suspect the next products that we build will get even further velocity gains just by having done this stuff already and implemented in a way that's reusable. Now again, nothing's for free, right? So there were some risks with this approach and some kind of negative things. So the positive definitely outweighs the negative, just so I'm being transparent. So one thing to bear in mind is that the core team, we've actually all worked together before, and again, a bunch of experience. So if it was a team that we built from scratch, I'd be a little bit more worried, just from a communication standpoint and getting everyone to gel. But again, we all have experience working together, so that wasn't an issue here. The other thing is that Kotlin on the server side world, it's sort of new, right? So I wouldn't expect to be able to find backend Kotlin developers really easily. Now that said, we're having a bunch of success onboarding Java developers to Kotlin. So developers who are familiar with Kotlin or familiar with peripheral JVM languages like Groovy or Clojure or Scala, I wouldn't suspect it'd be too difficult for them to ramp up on Kotlin. Again, on the Kotlin piece, some of the Kotlin Spring Boot intersections were nascent and not well documented. That's not to say we couldn't get it to work, but they're just things that, again, from a documentation standpoint, I suspect that we were maybe some of the first people doing it just based on some of the issues we saw and some of the gaps in documentation. The build process, so in the Kotlin world, Gradle is used, is preferred over Maven. It's a religious war on which is better. In my experience, I think Gradle is a little bit more complicated to get going. Although that said, once we had it going, it became kind of transparent in the background. And then the final piece, and this is probably the basis for another talk, is that we very much underestimated the amount of effort required in addressing ad hoc queries by the front end. So a lot of the front end stuff was actually less around CRUD and more around reports and ad hoc graphs. And we shouldn't say trouble, but it was somewhat awkward to map, RESTful API concepts to these ad hoc queries. So because that, we're beginning to look at a parallel GraphQL API in addition to the current CRUD API from a RESTful standpoint that we're exposing. So that's all I have for today. Thank you for listening, and I'm looking forward to the Q&A session following this. Thanks.